Hello, today we are going to look at another number theory problem in the 650 plus range on the GMAT-CAT. The question reads as follows. How many pairs of integers x and y exist such that the highest common factor of x and y is 35 and the sum of x and y, x plus y, is 1085? Please take a minute to understand the question and try to solve it on your own. If you can't do it, let's proceed with the video. So I'll write down the essential facts that the problem gives us. So we know that x and y are integers. The question also states that the highest common factor of x and y is 35 and the sum of x and y is 1085. With this information, we could rewrite x and y as follows. Let's assume that the highest common factor of x and y is h. So x could be rewritten as h times a and y could be rewritten as h times b, where h is the highest common factor of x and y. That would be 35. Hence, we could rewrite this equation as so 35 times a plus b would be 1085 and a plus b would be 31. Let's note it down. To further solve this equation, we assumed that the highest common factor of x and y is h, which is 35, which automatically implies that the highest common factor of a and b should be 1. If this were not the case, then the highest common factor of x and y would not be h, that is 35, and it would be something else. If you assume that the highest common factor of a and b is 2, then the highest common factor of x and y would not be 35 but 70. Hence, this condition is not applicable. Hence, the highest common factor of a and b should be 1. If the highest common factor of a and b is 1, then a and b should be coprimes. Two numbers are coprimes if the highest common factor, that is the highest factor which is common to both the numbers, is 1. So a and b are coprime only if the highest common factor of a and b is 1. If this were not the case, a and b would not be coprime. So we have this information that a and b have to be coprime and that the sum of a and b should be 31. With this, we could list the values of a and b that add up to 1 and also check if a and b are coprime. So let us build a table. Let us start with 1. Why do we start with 1 and not 0? Because if we start with 0, then the highest common factor would not be 35 and x would be equal to 0. That's why. So we start with 1. So if a is 1, then b has to be 30, so that the sum is 31. A and b coprime is the only common factor to both the numbers is 1. Similarly, we start with the value of 2, b has to be 29 for the sum to be 31. So we keep listing each and every number and see where we identify the unique values of a and b that add up to 31. So let's see, 4, 5, 6, 8, 9, 10, 11, 12, 13. So that would be 28, 27, 26, 25, 24, 23, 22, 21, 20, 19, 18, 17, 16. Here, so you can see that it all adds up to 31. So let us take two numbers and at random and check if they are coprime. Let's say 4 and 27. The only factor common to both the numbers is 1. So they are coprime. Similarly, let's take a random number 8 and 23. The only number common to both, the only factor common to both the numbers is 1. So it's coprime. So similarly, if you take any of these numbers, any of these values of A and B and check for their coprimeness, then you would see that these numbers are coprime. So we continue this, making this list till 15, and if you look at 16, these numbers are coprime, but then these values are no longer unique because the value of A or B, they are basically the same. So you can stop at 15 and we could see that the total number of pairs of integers x and y, so that HCF of x and y is 35 would be 15. So this is the answer. So we have 15 pairs of numbers such that the highest common factor of x and y is 35 and the sum of x and y is 1085. So 15 is the answer. I hope you enjoyed this video.